This is a sneak preview of the Voice of Lancelot speakers. Jim asked me to send a few shots of my new speakers, and this is something a little better. So here it is in the flash and in the wood and alnico magnet reality. So let's see what we have here. So this is the cabinet. It's made of maple plywood, and the driver is the Altec 515C, and we have a compression driver which is the 288, and it's a 16 ohm compression driver, and it's the H series. And I also have the crossover on the outside. It has a separate little chassis. So basically that's a Macintosh autoformer to step down the signal level, because these fellows are 112 dB per watt meter efficient, and these are only about 98 dB per watt meter efficient. So we have to step down the compression driver to meet them at the same level. And in the crossover, this is only the high pass crossover for the tweeter. The low pass crossover for the woofer is not there. It's at the amp side. So if we follow the speaker wire and we follow it to the amp, on the amp side, that's a 10 millihenry inductor, and that's the only thing. That's the low pass crossover. So that creates with this Altec speaker driver low pass filter at 285 Hertz first order. So it's rolling off really low. And the compression driver, the high pass for it is 565 Hertz. So it's going pretty deep, but these compression drivers can go quite deep by themselves. And as you can see, I'm running this as a bare driver, so there is no horn attached to it. And I made a test to compare it with horn and without horn. So I put the horn on the other speaker and this as bare driver, and surprisingly enough, for high frequencies like 10 kilohertz plus, without the horn, the bare driver is much louder at 10 kilohertz. Of course, when you put the horn on it, 1 to 3 kilohertz will be way higher output than with the bare driver. However, that was tested with the driver firing towards me. When you fire the driver upwards, in that case, I'm also using the top of the cabinet as a buffer extension. So basically this that you see around the driver acts as the loading at the low frequencies. So this can load it down to 300 Hertz. And when I played around with the crossover, like lowering it from 2 kilohertz down to 5, actually I tried as low as 550. There's a major change in tonality, and the 288 can easily handle down to 500. And there's a really nifty feature here at the crossover. So you see I have multiple tabs. That's on the input side, and that's the negative terminal, and for the positive I have 3 terminals, and they are hooked up to additional dropping resistors. So if I hook it up here, then it means that at 1 kilohertz the output level is at 102 dBs. If I go down here, it's at 100 dB, and here 98 dB. So I can level the highs upper or lower, and that's an essential feature because there's many recordings which are mastered with too much high frequencies, and in those cases you really need to drop those few extra dBs. And there's a major shift in the tonality when you add those couple extra dBs to drop, because these compression drivers are so efficient that even like even like a 2 dB change is really apparent with them, and then can change the experience from a really ear-splitting experience to a fantastic experience. And why does the bear driver work without a horn? Because it's already a horn. So when we look at it, the compression chamber actually behaves as a horn. So this is the horn itself, and this is the mouth of the horn. So it starts widening up to this is about like 20 centimeters, and then we have an extension. So this can handle frequencies down to 1 kilohertz. So basically the bear compression driver is a horn you have the horn throat and the mouth working down to 1 kilohertz, and if we fire it towards us, then that's what we get. And when Jimmy and Greg and Erwin, you heard it, that's how you heard it, that when it's firing to you, it goes only down to 1 kilohertz, and then there's a gap between the two. But when you heard it, then I had the woofer running much higher, so it was crossed over about 500 hertz. So now I could move the crossover to a much lower frequency. So now basically the woofer is going uncut full range up to about 260 hertz or so, and then it starts dropping. However, you see that I have made this little horn mouth for the attack, so it means that this adds a little boost to frequencies between 300 hertz, which is the inner diameter, to 500 hertz, which is the baffle diameter. So for those frequencies, I have an increase in the driver's output, and it does come up to 500 hertz to meet the compression driver. So I have a seamless integration now between these two. And the side effect of this is something really humongous. It means that this behaves as an omnidirectional speaker. I think it's kind of something unheard of in the history of speakers so far, to have an omnidirectional horn speaker. And this is the very first speaker like that on the planet, because at these low frequencies this already behaves as an omnidirectional driver, and because we are firing it up, we are using the compression driver also as an omnidirectional driver. And when we go here, let's check out what happens to the frequencies. We looked at, oh, and I haven't talked, I have an ultrasonic tweeter as well. This is familiar to all of you. So the cone itself, it works down to 40 hertz. So when I look at the Win ISD simulation at 37 hertz, that's where I have the really high electric resistance for the driver, and that's where the port is taking over. And between actually, let's see, let's go down to the port. So here down we have the port there, and I let in the cat because she wants to come in. Okay, so here this is actually the mouth of the port, and if you look, you can see behind Machi. Here's Machi. She just came in from outside. So it's completely open, and the port is actually, let's see, it's up there. So it has a really nice opening. So it's tapering out like a real horn, and that small taper opens up to a even wider taper out here for both front and back. So this behaves as an excellent impedance transformer for the low frequencies. So as the sound is coming out at high pressure through the port, which is a slot port across the length of the entire speaker, then that high pressure gets lower and lower, and basically with this method I have a pressure drop of 5 times compared to what's the real air pressure coming out from the port. So it means that I have really negligible port wind speeds, even at really high output, only a few meters per second, which is like almost like an order of magnitude less than what most really good speakers use today. And that means that I do not have that artificial pressurized feel for the ports, and there's no port chuffing and as some people say it, port farting. That doesn't exist here. The inside of the speakers, they are actually a folded pipe. So I have a fold in here, so when we look at them, maybe we have to go a little further. Not too much light. So inside there's a panel at the center of the speaker. So when the driver is working, then the air column is formed as like this. So all the internal pressure is organized to a really nice even air column, and the port exit it exits down there inside behind that baffle. So this is actually a quarter wave pipe but the quarter wave pipes have the regular openings, and this is not loaded as a quarter wave pipe, but it's loaded as a bass reflex cabinet with a slot port. What this entire thing means is that down to so like about 100 hertz or so, we have the driver's output, which is the main output of this cabinet, and below that we have increasingly more and more the internal pressure taking over, because it can couple to the internal compressed air better than to the air in the room. So that internal air is organized down to 40 hertz. So the height of this folded horn inside, that's a little bit over 2 meters, and it corresponds to about 39 hertz when I do the calculations exactly. So down to 39 hertz we have the pressure waves organized. Instead of being random pressures causing random fluctuations, what most speakers do, and in that case you need like super heavy bracing to prevent those random fluctuations from showing up in the sound. Now we have a laminated airflow, so that the energy is focused towards the lower end, and it's focused down to 40 hertz, and then we have the port down there that fires down, and the port converts the energy from 40 hertz down to 15 hertz or so. So the port is tuned to a little below 18 hertz, and this means that the ports allows only sound from 1 octave higher and 1 octave lower than 18 hertz to go through it. And because of that, and because of the nature of the slot port, there's no high frequency port resonances coming through here. And one more thing, because we cross this over at 260 hertz, that's why there are no high frequency resonances in the cabinet. So in the port we do not have artifacts that affect these higher frequencies which are coming from the driver. And actually, when I use it without the compression driver, so only feeding the woofers, these low frequencies, they really sound like just some deep gurgling. So there's no characteristic, no directionality to them. So it's and when I add the compression drivers, then it becomes like a human sound. So this is a fantastic interpretation of speaker design because we have all the information that defines dimensionality, uh, uh, space, and everything that the ear picks up as intelligible sound and music comes from a single source. So basically, this is almost like a single driver speaker because everything that the ear can make sense of comes out from one compression driver, and then everything from that the ear cannot localize, cannot pinpoint, comes from this box, which is essentially a gigantic subwoofer tuned to 18 hertz. So that's what how these speakers work.